Hello learners, in this lecture we will see how to apply the loads on the slabs and also on the beams. So before we try to apply the loads, we should have a basic understanding what all are the different loads that acts on the building. So I'll quickly go through that. I'll be not explaining it in a great depth. So these are different kinds of load that acts. One, we have a dead load, we have a live load, we have a wind load, we have earthquake load, we have snow load, then we have a blast of the impact load, we have this offshore structure, in that we have wave and current load, and then we have this water pressure if you're constructing a dam and all. So right now we are constructing a small residential building, so we'll be considering only the dead load and the live load. Right now this is how it looks, right? So we human beings are called as live load. We live loads are also called as imposed loads. And the wall what you have, the beam what you have, the slab what you have, they all are called as dead load because they're permanent. They're not going to move here and there, right? The wall, the floor and all. But we human beings, the furniture, we all are live load. So that is why we call ourselves as an imposed load, right? So with this understanding, I'll try to move ahead. Now, how do we calculate the load? So whenever we want to calculate the load, first we need to define the load. So I'll go to the option called define, and there's option called load patterns. So by default, ETABS is going to consider two load, that is a dead load and live load. That is enough for us. But actually what we do, whenever we apply a load, let us say this is a slab what I have. Over the slab, I'm going to put my tiles and all, right? I'll show the image for that. Yeah, you can see it here. This is a floor what I have. So over the floor, I'm going to put the cement mortar, and over that I'm going to lay the tiles. So this will also add the weight on my floor, right? So this load what I'm going to apply, they are called as SIDL load. I'll write it here. They're called as SI, that is superimposed dead load. Over the floor, you are applying this load, that is called as superimposed dead load. So we need to calculate this load, how much load it is coming. So yeah, I'll tell you how to calculate that load. So to calculate that load, I have done a calculation here. Yeah. So the flooring, we call them as SIDL load, that is called as flooring finishes. So 20.4 is the unit weight of your cement mortar and the tiles, and the thickness that we are going to use, right? The thickness, what you can see here, the thickness, what you can see, that is usually 50 to 75 mm, but I'm considering it has to be 75 mm. So what you need to do, just multiply that 20.4 into 0.075. It comes out to be 1.53 kilonewton. So this is a SIDL load that is acting on my floor. So what I'm going to do, this is already, so what I'm going to do, first I'll create that pattern. So let me write this as SIDL, that is superimposed dead load, and in the type what I'm going to do, I'll say this is my super dead. Okay, and then I'll say add new load. So what has happened, the load pattern has been created. One is a dead load, the second is a live, the third is a SIDL, and click on OK. And now select the slabs where you want to put that load. So I'll again click on all stories. I'll click on all stories. I'll select this slab, this slab, this slab, this slab, and this slab. Then I'll go to option called assign. I'll go to option called shell load. Then I'll go to option called uniform. And now under the SIDL, under the SIDL, I'll select that. And what was the load we calculated? Okay, it was 1.5 kilonewton per square meter, 1.53 kilonewton per square meter. But here, can you see the units are in feet square and all? Since we had kept it in feet and inches, let me try to change that once. So what I need to do, I'll go to units. I'll put it back to metric SI defaults. Okay, I selected the slabs again. I'll go to assign, and I'll go to shell loads. I'll go to uniform, and here under the SIDL, let me put that load as 1.53, what I've calculated, right? This is 1.53 what I'm getting, and I'll say apply. So can you see that live load, whatever dead load we had calculated SIDL, that has been applied on all the floors. Similarly, we have to apply the live load as well. Now, to apply the live load, you have to refer a code book, that is Indian Standard 875 Part 2. And based on the type of structure you are doing, the live load is given. Now, let us say we are doing a residential building, right? So in the residential building, if you're doing a all the rooms and the kitchen, you have to consider your live load to be 2 kilonewton per square meter. If you have a toilet and a bathroom, there also you have to consider 2 kilonewton per square meter as a live load. Now if you have a balconies, then you have to consider it as to be 3 kilonewton per square meter. If you have a corridor, passages and a staircase, you can consider the live load to be 3 kilonewton per square meter. So this is for a residential building. In the same way, if you're doing some other project, let us say if you're doing a educational building, in that case for the classrooms, you have to take 3 kilonewton. If you have a dormitories, you have to take 2 kilonewton. Similarly, if you're doing an institutional building, based on the type of the building, the different load has been given in this particular code book. Right now, we'll not try to get into all that thing. We'll just consider the building what we are doing. It's a residential building, a small house, and we have a rooms. There we need to take 2 kilonewton, and wherever we have toilet and bathroom, there also we need to take 2 kilonewton per square meter. That means in entire structure, we have to take a 2 kilonewton per square meter of my live load. So if I want to show the AutoCAD planning, I'll go to the AutoCAD, and if you try to see into this, so this is a kitchen what I have. On this slab I need to put 2 kilonewton per square meter. I have a bedroom, here also I need to put 2, and I have a living room, here also it will be 2. Again I have a bathroom and a wash basin here. That means here also I need to put 2 kilonewton per square meter. So throughout all the slab I need to put 2 kilonewton. So what I'm going to do, again I'll select the slabs, all stories, select all the slabs, right? All the slabs have been selected. Go to assign, and then go to shell load, go to uniform, and this time select the option as live load. And now instead of 1.53, we have found that live load to be 2 kilonewton. I'll select on 2 and I'll say apply. Now can you see that 2 kilonewton of the load has been applied? Now just in order to see what load is applied where, what you can do, there's an option here called display shell load assigns. If I click on that, and if I say I want to see what is SIDL, click on SIDL and say apply here. So we had applied 1.53, you can see the same load here. Now if you change it from SIDL to live load, click on live load and say apply. What was the live load you had applied? 2 kilonewton per square meter. Again, you are able to see all these things, right? So in this way you have to apply the load on your floors. Now coming to the wall, right? So wherever we have beam, there I'm going to consider the wall load, right? So what I'm going to do, I need to calculate the wall load. Now for wall load calculation, the simple trick is that we know the unit weight of my bricks. The unit weight of my bricks is 20 kilonewton per square, kilonewton per cubic meter, right? And the thickness of my wall is 230 right, which comes out to be 0.23, right? So what I'm going to do, I'll multiply this. 0.23 is the thickness of my wall, multiplied by the density of the brick, which is 20, into till what height you are going to construct this brickwork. Usually the floor to floor height what we have, it will be usually 3 meter. So up to 3 meter I'll consider the brickwork. Okay, I'll multiply this by 3 meter. Suppose if your floor to floor height is, let us say, 2.5 meter, in that case you have to multiply this by 2.5 meter, right? I'm not going in a depth. I'm just trying to cover a basic thing. Again, there is a lot of calculation here, but as of now, for our understanding, just understand that floor to floor height is 2.3 meter and try to calculate this. So what you have to do, 0.23 into 20 into 3 is what I'm doing. So I'm getting 13.8. So this 13.8 kilonewton per meter, this is a load that is coming on all the beams due to the wall. So what I'm gonna do now, so I'll select all the beams here. Okay, I'll select this beam, I'll select this beam, I'll select this beam, I'll select this beam, this beam, this beam, this beam, this beam, this beam, and this beam, right? But in the terrace portion, I'll be putting a parapet. I'll show you how it looks. See, this is a brickwork load what we have calculated. You can see this wall. On this wall we have done this brickwork, that is the load what I'm calculating. But if you go to the terrace portion, in the terrace we are putting this parapet, and the height of this parapet is just 1 meter. So the load coming on that terrace portion is very less, so you don't have to calculate the entire length. So I'll be explaining you how to do that calculation. Okay, so what I'm going to do, I'll selected all the beams, but what I'm going to do, I'll go to the terrace floor, I'll go to the story 4. Okay, and in story floor I'll make this as one story, because I don't want my beams to be selected here. I'll untick all these things. I made it as one story, so only the change will happen in story 4. Unticked all these things. I'll unselect all these things. So you can see here, right? So only in story 3, in story 3, story 2, and story 1, all my beams are selected, and in terrace it is not selected. I'll go to option called assign. Now this time I'll go to frame element, that is a frame load, and I'll go to a distributed. And here what will happen, instead of dead load, I'll consider this has to be SIDL. Again, it's a superimposed dead load. Don't look into all these things, directly come here. What is the load we calculated? It was 13.8 kilonewton, right? I'll say 13.8. I'll enter it here and I'll say apply. Now can you see it on all the beams, I'll show it. Can you see on all the beams the wall load has been assigned, right? Yeah, now coming to the terrace portion, that is the top. This is my terrace. Okay, the story 4 is a terrace portion. Here I have to add my parapet wall load. So the parapet wall load, what you have to do, you have to calculate in this way. The parapet load will be, let us say the height of my parapet is 1.2 meter. Okay, the height of parapet is 1.2 meter, and let us say the thickness of that uh, parapet wall is 100 mm, which comes out to be 0.1 meter. And let us say the it is made up of brickwork and the unit weight of brick is 20. Now try to multiply this, that is 1.2 into 0.1 into 20. If you do that, no, you are going to get 2.4 kilonewton per meter. So this 2.4 kilonewton per meter is the load that is applied on this beam. You can see a beam here, and this is a parapet wall. So this load is applied on this particular beam. So what I'm going to do, I'll go to the story 4. I'll select only the outer beams, because only on the outer beams your parapet load will be acting. These inner beams are not subjected to anything, right? I'll select only the periphery, that is the outer beams. I've selected all the outer beams. I'll go to assign, I'll go to frame load, I'll go to distributed, and now again under SIDL, let me take that load as 2.4, select on 2.4 and say apply. So can you see only on the outer side that load of 2.4 has been assigned. That's it. We have put our dead load, we have put the live load, and the frame, I mean the wall load is also applied on all my beams. Yeah. Now the last thing that we need to do is the, if you come to the base, we have to give the foundation, right? So this is my foundation. You have to give a support to that. So what I'm gonna do, I'll come to the foundation and I'll select one story. I'll select all my joint in this way. Try to select the joints. So I'll keep my cursor here and try to drag it. So you have 6 columns, right? So only 6 joints will be selected. You can see it here. 1, 2, 3, 4, 5, 6. You can see 6 joints are selected here. Then I'll go to assign, and assign this option called joint, and there's something called restraints. So now I'll make all my base as fixed support, right? So what I'm going to do, this option called fixed here, click on that, and I'll say apply. The moment I say apply, what will happen, everywhere the fixed support will happen. Then your building will not move in X direction, Y direction, as well as it will not try to rotate. So I made all my base as fixed support, right? So in this way you have to give the support to all your buildings. I mean, to the joints, whatever joints you have in the base, this is how you have to do. Similarly, if you want to give it as a pin support, what you could have done, you should have gone to assign, joint, and restraints. Here, this is a fixed support, this is a pin support, and this is a roller support. So practically, pin support we try to do in steel structure. In the RCC structure, always we go with a fixed support unless there is a need for the pin support. This roller we don't use unless we do some manual problems. That's it. And this is none. If you don't want to assign any support, you can click on this and you can say apply. None of, I mean, no supports will be assigned. As of now I require fixed support, so assign this everything here, right? And these are the translation in X direction and translation in Y direction. That is, it doesn't have 6 degrees of freedom. This is what you mean by translation X, Y, and Z. So I'll close this thing. So I assign the support, right? That's it. Next is that we have to define the load combinations, and then we have to run the model. So in the next lecture, we'll try to see how to prepare the load combinations and how to run the analysis for this particular building. I hope this is understood up to here. I will see you back in the next lecture. Thank you.